Hello, this is Jeffrey Frankel with Solutions in Chemistry. I can help you pass the IB exams in chemistry.
In this problem, two solutions of sodium chloride of different concentrations are mixed, and you are asked to find the concentration of the final mixture. I will show you how to deal with the calculation, but first let me show you how you could eliminate some of these possible answers by looking at them carefully. Look at the first answer, A, 0.15. This is more dilute than the most dilute of the two solutions, 0.2 mole per decimeter cubed. It is impossible to get a final solution that is more dilute than either of the two solutions used. Therefore, A cannot be a possible answer. Look at D. Similarly, this is more stronger, more concentrated than the most concentrated of the two solutions. This cannot be an answer either. Look at B. This is an interesting one. 0.4 is halfway between 0.2 and 0.6. For you to achieve a figure of concentration of 0.4, you would have to mix equal volumes of the two solutions, and equal volumes were not mixed. Therefore, B is not a possible answer. This leaves only C, 0.5. Now let me do the calculation. The way to do this calculation is to use the formula C equals N over V. You may say you have difficulty remembering formulas. You can't remember them. This is one formula you have to remember. However, it is given in the question. Concentration equals N over V. Concentration, moles, divided by decimeter cubed. C equals N over V. We will now rearrange this so that N equals C times V. These are the two formulas we're going to use. We're going to use N equals CV first, then C equals N over V. We're going to use N equals CV to find the number of moles, and then the C equals N over V to find the concentration. 0.2 times 10 over 1,000. I put the 1,000 in because the volume is measured in centimeter cubed and we want the answer in decimeters cubed. And the relationship is 1,000 to 1. Plus 0.6 times 30 over 1,000. That is N. That's 20 over 1,000. I'll leave it like that. Now in paper 2 you'd put it as 0.02 moles. You get 1 point for the formulas, 1 point putting numbers in, and 1 point for the final answer. But this is paper 1, and the examiners are only interested in a correct answer. Now have N. We're going to use the other formula. C equals the value of N, which is 20 over 1,000. And the volume is 10 plus 30. 10 over 1,000, 30 over 1,000. Now we can eliminate the thousands, and that equals 20 over 40, which equals 0.5, which is the same answer as before. Now look carefully at this. You can see the formula can be simplified. Simply look at the numbers given in the question. C equals 10 times 0.2 plus 30 times 0.6 divided by the total volume, which is 10 plus 30, and that equals 20 over 40, which equals 0.5. If you do this, you can do the question in approximately 30 seconds. There's no need to put the thousands in, just the numbers that they give you in the question. So all you're using is these two formulas. Concentration equals number of moles over volume, and number of moles equals C times V. When you look at this problem, you're expected to realize that the concentration of sodium ions is the same as the concentration of sodium chloride or sodium bromide. So we're going to use the formulas that we developed before, which are in the questions. Concentration equals moles divided by volume. C equals N over V. Rearrange it. N equals CV. So we used N first of all, to calculate N first of all from that formula, and then calculate the concentration from the other formula. Now I'm going to use the simplified version as discussed before. I'm not going to introduce thousands, simply going to do 10 times 0.3 plus 20 times 0.6 divided by total volume, which is 10 plus 30. 10 plus 20 equals 30. That comes to 15 over 30, which is 0.5. And so C is the answer. Now, interestingly, you could have used the method of elimination, looking carefully at some of these answers. A, 0.3. Clearly that is not a possible concentration because you started with one solution which had a concentration of 0.3 and you added a stronger one. Similarly, D is not a possible answer. You started with a solution of 0.6 and you added a more dilute solution to it, so that's not possible. B is an interesting one. You started with a concentration of 0.3 and you added quite a lot, twice as much, of a much stronger solution. In fact, it was twice as strong. Unlikely to be B. Unlikely to be. So that also gives you C as the answer. However, this YouTube video helpful, please look at all my other YouTube videos. Thank you very much.